So like I said, I'm Blake. I'm the CEO of Sofab Inks, and this here is Perovskite Connect. I think it's safe to say that everybody in this room is fairly optimistic around the promise that is perovskite technologies. So I'm going to take some assumptions and some liberties on that front, and not go into full detail all the efficiency benefits, but just largely speaking, perovskite technologies, they do present the largest step improvement in efficiency in photovoltaics in modern PV history. So a lot of reasons to be optimistic, and really we should be optimistic about the technology. All that to be said, the economic impact, there are challenges. Ultimately, for perovskites to really achieve true commercial dominance and make an impact on the solar industry, they need to demonstrate durability. And unfortunately, the durability demonstrations that they need to achieve aren't just simply academic durability demonstrations, they are bankable durability demonstrations, which creates an entirely different class of evaluation metrics that you need to achieve. Virtually every techno-economic analysis that evaluates perovskite technologies and the feasibility of the technology long term assumes that there's 25 years stability. So durability really is the greatest lever to determining whether or not a perovskite technology will achieve commercial viability. This technology is additive in cost to traditional silicon technology in most tandem architectures, most of the module architecture being 81% roughly fixed cost, with the silicon and the module tabbing and wiring on the back end. So ultimately, we're working with slim margins when we're talking about economic improvements for the technology. And if you just simply decrease your lifetime by 5 years, from say a 25-year assumption to 20 years, you're approaching a point where you're seeing diminishing returns by incorporating perovskite technologies into the module. If you reduce that to 15 years, your LCOE value begins to approach a point where it is no longer feasible and honestly is more detrimental to the overall solar industry by incorporating perovskites on top in tandem architectures. So really, this is just one sort of quantifiable metric that you can look at to say, how do I measure how efficient, economically viable is a perovskite technology? And it all hinges on durability. So that's really where Sofab is positioned into the broader perovskite ecosystem. So our proprietary technology and where we're value adding to the ecosystem is we make functionalized metal oxide nanoparticles, enabling durable, scalable perovskite technologies. Our initial product offering that we most frequently highlight and is really our beachhead material offering for the ecosystem is our tin oxide electron transport layer. It is a direct drop-in replacement for C60, which a lot of the perovskite manufacturers in the room will understand how problematic C60 truly is for their manufacturing ecosystems. And so what our technology approach enables, it lowers CapEx, reduces material costs, we can increase module lifetime by incorporating materials that are more compatible with the metal organic perovskite materials. We can maintain record efficiencies, but do it via scalable deposition techniques, primarily slot die, some preliminary work and some inkjet coated applications. And then we're beginning to validate this material at pilot scale, which we'll touch on a little bit later with some of our more demonstratable results. And we're compatible across multiple different architectures. And also further, the platform that we've developed, we can tune these materials to make them more optimized, tunable for next generation stacks, different architectures, and provide a whole suite of different customizations that most material suppliers do not offer in the space. And so when we're talking about our initial product, TinFab, the first thing you have to consider when you're trying to deposit a material directly on top of the perovskite is first, do we damage the perovskite layer by any of the process that we use? And our approach was metal oxide nanoparticles, so first we had to overcome solvent incompatibility issues. So we take tin oxide nanoparticles, we functionalize the surface of them to make them soluble in nonpolar solvents. That enables us to do solution phase coating directly on top of the perovskite. We've confirmed that we're non-damaging through a few different methods. First, you can look at SEM images just straight down on the film itself, and we see that we are non-damaging to the morphology of the perovskite